Would you mind talking a little bit about neurotransmitters as we have been talking so much about opioids and cannabis, and those seems to have a really direct effect. Would you mind elaborating on that concept a little bit and how the dopamine and the GABA works in those cases?
Yeah, of course. Yeah. I mean, we are pure chemistry, right? As you can see. So yeah, our brain works with chemistry,
Yeah.
right? So we have the
Hmm.
neurotransmitters that we can say they are like messengers. They are messengers that help to communicate our neurons to do different things, depending on the part of the brain that we are talking about. So most of the drugs of abuse, we were saying before, they are psychoactive. So basically, they are going to have a role, they are going to have an impact in the central nervous system. And how they do it, most of them, messing with the neurotransmitters, right? So depending on the drug, they may act on dopamine, on serotonin, in the GABA receptors. They can act at different levels, but basically they're going to mess with those levels. In many cases, what they are going to do is to produce a increase in these neurotransmitters. So for example, amphetamines and cocaine are pretty similar in that sense. And if I remember correctly, both of them act with the dopamine and the serotonin, and they're going to increase the levels of them. So you have an overstimulation. That's why they are stimulant drugs, right? Because basically you have more dopamine and serotonin than you should. That's why you are with high stimulation. The intimate mechanism by which they do that is a little bit different. One prevents the neurotransmitter to be reabsorbed in the neuron, and the other one produces a major release of the neurotransmitter. So, because I was saying before, the neurotransmitters are messengers that communicates neurons. So neurons are the cells we have in the brain, basically. And they are separated by a small gap that is called the synapses, right? So how they talk? Well, they release that messenger, that neurotransmitter in that gap, and then binds to certain receptors in the next neuron that tells get excited or get not excited. And basically is that communication. And depending on the region of the brain, this will be a higher heartbeat or breathing more quickly or not breathing or tremor or convulsions, depend, all right, or hallucinations, it depends. So the thing is that for example, with the stimulant drugs, they increase the number of neurotransmitters in that gap. So the neurons are overstimulated, right? Then, for example, with the GABA receptor, I think GABA receptors are more the target of anxiolytic drugs like benzodiazepines. Anxiolytic, that means that these are drugs that are used to reduce your anxiety, to calm down, right? So the GABA, I would say, is like a switch that makes everything to calm down in your brain. It's like a depressor, right? So that's why it's the therapeutic target for this kind of medication to make the people basically to be more cool and to be calm down, right? So everything is, you see, is chemistry, switch on, switch off, stimulation, depression, and depending on what you do, you will modify that accordingly.